So I'll talk a little bit about micromolding. I'm sure many of you are familiar with the benefits of plastic injection molding of optics, so I'll run through some of these benefits. First of all, you can mold many shapes that are very, very difficult to grind in glass or other hard materials. Sizes can go down to 1 millimeter, and with some special expertise, even smaller than that. Tolerances can be held to 2 microns. That's not easy to do. It's not always recommended. Commercial tolerances are more like, plus or minus 5 or 10 microns. But this is doable. You can get very high quality surfaces out of molded parts. Easily Lambda over 4. You can build in assembly features like mounting flanges, spacers, threaded holes. They're coatable, and plastic anti-reflection coatings have really improved over recent years. There's a lot more people doing them now. They've gotten a lot better. There's rapid prototyping capabilities by diamond turning. And one of the advantages is you can generally diamond turn in the same materials that you will ultimately be molding in. So you can really do some very precise early validation or verification of designs. Diamond turning doesn't have quite the surface finish that molding does. You can get maybe 75 to 100 nanometers RMS from diamond turning. Diamond turning is also used to make the inserts in the molds, but when you mold, the plastic tends to skin over, and you don't get that surface roughness.
Good luck with the internship. Thank you.
And of course, plastic optics can be very low cost compared to grinding and polishing glass, particularly if you go to multiple cavities. Now here's an example of an element that Syntec has recently molded for us. This is the element right here. It's about 1.45 millimeter flange OD, and so all the rest of this gets cut off. These runners are thrown away, so the runners are much bigger than the part. Pick this thing up, it's hard to see what the part is. But, this is used as part of an objective lens design. It's an all-plastic design. There's 4 elements in it. It achieves a 90-degree field of view, diffraction limited almost right to the edges, and a working distance range from about 8 millimeters to infinity. Great depth of field on it. This is another lens that Syntec is molding. This is for a 360-degree camera, so hopefully you can see that there's an axicon shape here. So it's actually looking out in a 360-degree band. And then there's another element in the middle that's picking up the forward view, the near axis view. And then image stitching software that puts all that together to give you a full 360-degree hemispheric view with basically a single optic. Very impressive.